G'day frothers, welcome back to the bush. So today I'm going to be trying out this thing. So this is a Schmidt hammer, Swiss hammer, rebound hammer. So it's a rebound hammer that was invented by a Swiss guy called Schmidt. And it is actually for testing the compressive strength of concrete, or estimating the compressive strength. It actually tests the hardness, but because concrete's properties are pretty well understood, you can infer the compressive strength from that. Now, I am told by some geologists that you can actually use this to estimate the compressive strength of rock, and I thought, you know what? I'm trying to do exactly that, so why don't we give this a shot. Got our beautiful sandstone test site over here. So yeah, let's give it a try. So this thing, as usual, was the cheapest decent looking one I could find from Alibaba. There you go. So it's got this chart on here. You rebound, you bounce the hammer off the material, and the amount that it rebounds to go onto this chart here, and that'll tell you. So this is compressive strength, and then this is your rebound value. So 40, if we just go to 40, it'll be about a 50 newtons per millimeter squared compressive strength. So that's like 50 MPa. Quite a nice little kit. It comes with some spare springs and stuff. I assume the calibration is, good enough for my very rough estimates. And this is actually for dressing up the surface of the stone, or the concrete. So I've just brushed off some pieces, and let's try this. There you go, so it's nice and flat, and hopefully we've got some crumbly parts off. Let's just do a few more. Cool, so I'll get going with that, prep all these little sites around here, and then get hammering. Okay, so this thing has this hammer which rebounds in there. Basically the procedure is you just push it into the material. So I just cleaned this spot here. You push it in. So the rebound varies depending on the orientation, so I'm going to try and be as horizontal as I can. Okay, and so we got, it's about 48. I'm just wearing this for the camera. I'm really surprised how repeatable this thing is, given that this is not concrete. It's all, fine. There's all these grains, different stuff for it to bounce off. Pretty impressive, actually. So this band I just tested here is noticeably harder. Like, it's finer grain. This band where I put these bolts here, harder grain. It's harder, finer grained. So that's the part I just tested there. That's probably atypical for the sandstone in the region. Above that and below that, probably more typical. So let's see if they're different. Okay guys, so I've tabulated all these results, and after filming I also went and did some readings at the crag itself, so a couple of walls out there. 38. So here we've got the average rebound scores down the bottom, and I've just plotted them all up. So in that hard band, it was actually harder, according to the Schmidt hammer, so 53.5. Above that band, the stone was a little bit softer, and the stuff below the band, which did actually feel softer, like to the touch, 45.33. So one spot in the crag was 38, and another spot was about 50. Now, to convert the rebound value into megapascals or something useful, newtons per square millimeter is same as megapascals. So I just use this chart here. There are a few of them depending on your application, but I chose the cylinder 150 by 300 mil long. And I just chose this. I don't know what effect cylinder shape has, but I just chose this one because 300 millimeters was the biggest thickness that they had. So we're doing a giant rock. I figured let's go the thickest. And also we were hammering horizontally, so I used that middle line there. So now in red, we've got the newtons per millimeter squared, or MPa, as I prefer to say. The hard band was 56 MPa, 49.5, 42, and then over at the crag, 36 and 50. So if that's true, I am stoked with that, because that means that this stuff is harder than, concrete. Your normal concrete is 20 MPa, so that's going to be awesome to work with. So if these numbers here in red are even half accurate, then I am very, very happy with these results. I feel super confident in the sort of bolts I'm thinking of using. I think this is going to work out really, really well. It gives me great joy to see such big numbers for this. So that conversion chart is based on concrete properties, but there are a lot of papers out there if you want to do some Googling that sort of look into how you can use these hammers for stone as well. Looking at this paper here, we've got 50 rebound units equals sort of 60 MPa, so a little bit higher than what I was getting in my conversion chart. But if that's halfway accurate, then yeah, I am super, super happy with that. So this paper here seems quite good. They got a nice summary of previously published conversions. So there's all sorts of crazy things here. So for instance, this method here by O'Rourke, 702 times the rebound score minus 1104. Now that one isn't that accurate. Oh yeah, so R squared, that's actually like Pearson's R, that's a correlation. So 1 is a perfect correlation, so closer to 1 is better. So 0.94 is a very good correlation if you do that kind of formula. So O'Rourke, not that accurate. I mean, it's still good enough for my purposes, you know. So I'll do some more fiddling with these numbers in future and, you know, see if I can get a better idea of this. But, you know, I just wanted to point out that there are a lot of there have been a lot of other people looking at doing this kind of stuff. I am hardly the first one out there. So it's good to see there is a solid theoretical basis for doing this kind of thing. So I did read in one of those papers, you could expect a 25% error range. So that's what these little error bars here. So, you know, even if this is 25% lower, that's above 40, stoked with that. That's like, I don't know, 38, stoked with that. Even the lowest reading I got here would be above 20, in which case, you know, I'm still super stoked with that. It just means that this sandstone is, you know, not total trash. So I do consider these pretty rough estimates, but that's fine. I mean, we've got plenty of headroom. All good. Anyway, let's head back to the bush for the sign-off.
Well, there you go, guys. It seems to actually work pretty well. I'm very surprised how well this thing worked. A, because, you know, it is just some random thing I bought on the internet. And B, because the sandstone is so variable. I'm surprised how well the rebounding works, given, you know, it's bouncing off potentially different grains all the time. But very consistent numbers. The thing that sounded harder to the hammer also was a little bit harder with this, so that's pretty good. And overall, you know, pretty happy with how this has gone. Now I'm actually just winging this based on research I did myself. Maybe I'm doing this completely wrong. Maybe it's totally fallacious to try and assume this measurement is actually telling you anything about the compressive strength. So any purists out there, if you do actually know for real, if you get any pointers, or if you have another method that maybe climbers in my position where you're exploring a new area and you want to actually get an idea of the compressive strength of the rock so you know how big your bolts have got to be, you know, let us know. As always, this is a community thing. Right now I'm just trying all these things that I've wondered about. I've always wondered about this kind of stuff ever since I started climbing, or definitely since I started bolting. And of course I'm trying to do it as cheaply and as like open source as I can to try and better understand the materials we climb on and the mechanics of the bolts that we're actually installing and, you know, trusting our lives to. If this is the sort of thing that you're into, let us know. And if you want to see something else, I guess let us know too. I'll do what I can. Anyway, let's try and get a bit more open source knowledge going in the climb bolting community. Now, I'm actually going to try and pull all these bolts out in another attempt to estimate, you know, the compressive strength of the rock here, or at the very least, it'll tell us, you know, how big these bolts need to be. So anyway, it's all happening here, I guess. I really should go climbing at some point, but, you know, this is pretty interesting too. So anyway, thanks for watching. Scratch yous later. And as always, I don't know, climb, bolt, whatever. Get outside. Beautiful.